Now you know why the cost of car maintenance in Pakistan is low. Their maintenance level is beyond your imagination. Just by machining simple threads on the surface, two scrapped gears can be assembled into a new one. This kind of maintenance ability makes it impossible for parts dealers to survive. In Pakistan, there is a waiting period for replacing parts. Repair is not only fast, but also only costs 2,000 rupees. For the two seemingly scrapped gears in front of him, Fu only needs to replace the flower sword groove of the center hole to continue to use the gear with broken teeth. New gears are unaffordable, so repair and replacement are more cost-effective. Since it is necessary to keep a section with intact teeth this time, Fu first has to completely cut and remove the center hole that does not meet the requirements with a Rowan knife. Only in this way can the subsequent splicing and replacement plan be realized. Considering the need to ensure the splicing of the two, after the center hole is processed flat, the hole diameter of the wheel needs to be continuously expanded. Only in this way can the gear be prevented from breaking when rotating. The larger the diameter, the more balanced the force on the two. With the master's precise measurement of the card teeth, it is obvious that direct response cannot control the concentricity. Fu has to splice the thread at the inner wall processing. This not only allows the two to be concentric and tightly engaged, but also increases strength. After confirming that the threaded tooth tool meets the requirements, the gear with broken teeth can be cut in the same way. Since the previous gear aperture has been fixed, the master will cut the outer extension of the gear center based on this data to avoid the data after cutting being too different from the aperture. Obviously, when cutting horizontally, the width of the cutter head needs to be calculated. When it is necessary to ensure that the center hole is perfectly spliced, the master will use cardboard to compare and measure repeatedly to determine the correct feed position of the cutter head. Although the cutting of the Rowan knife has great limitations, the master will also increase the slot width as much as possible. There is more room for movement. Under the master's very skilled operation, the center hole with the slot has been successfully separated. If it is to be docked with the previous gear, the existing outer diameter data is far from enough. The master needs to make precise adjustments to make the cross-section smooth. The diameter data cannot be too large or too small. This is the key to this gear splicing. After detailed data comparison with the micrometer, the Rowan of the same tooth tool will be reproduced. Although they don't have high-end vertical control processing machines, the tool is very precise and then docked with the gear hole. The master rotates it effortlessly. It can be seen that there is no gap in the thread. When the two are flush, they are directly fixed with welding rods. If there is a height difference between the center holes of the two, the gear that has become a hole must be welded with welding rods to fill the gaps on both sides. Only in this way can the gear be more durable. It is obviously not possible to tighten the thread. Welding cannot avoid the formation of weld bars. In order to restore the original aesthetics, the rough weld bar surface must be cut and processed. The raised part is completely flush with the end face. While covering the welding marks, it can make the glossiness leap. Considering that the weld 8 on the other side completely blocks the groove, the master needs to cut the weld 8 horizontally to restore the basic depth of the original groove. These two scrap gears simply replace the center hole slot. What do you think of the Pakistani master's skills?